Okay, this tutorial is going to focus on choropleth mapping as a mapping technique used to present data to show a pattern across an area. Now, there's a few simple rules that you have to apply or obey when you're completing a choropleth map, and I'll go through those in this tutorial. I'll also look at some examples of different choropleth maps and give you some of the ideas about why this is a suitable technique, under what conditions you should be able to use this technique appropriately, and also some of the weaknesses of this technique. The first thing to note is that this technique is often known as a density shading map. And the most common way it appears in geography is where one color is used, as we can see in this map of Africa, and then a different shade or density of shading is applied to show higher values, in this case, dark green, or lower values, which in this case is light green. And that's the most common use of the technique. So one of the key aspects of this technique is your data has to be aggregated at some kind of level or area. So, for example, in this map, it's the area of a whole country, as we can see. But it doesn't have to be at a national level, the average of a country. It could be an area within a country, or actually, indeed, even at a much smaller area. And I'll show you some examples of that later on. Now, a few little things that you need to bear in mind is that when you're deciding how to complete it, you must have your colors in your key to be very distinct from each other. So you can see the difference between the different shades. Otherwise, it can become quite difficult in this one, for example, to see the difference between this shade of green and potentially this shade of green. The more categories you want, in this example is only 5, but if you have 10 categories, then it could be very difficult to see the difference between the different categories' colors. Another key thing to think about is where you want your cutoffs for each of your categories to be. Now, this map is showing the GDP of a country, the wealth of each nation in Africa. And those cutoffs don't need to be at equal intervals. They can be any cutoff that you decide as the map maker. So, for example, here, everything that's below 800 is represented by this category. And then everything from 800 to 1199 is in this category. And this category here starts at 1200. Now, it only goes up to 1499. We have a missing category. And that might very well be because there is no country between 1500 and 1699. Or it might be a mistake of the map maker. Once you've decided on your categories and how many categories you want and the color that you're assigning each category, or the shading density to be more precise, then you can go ahead and map the data as you can see. It is a recommendation when using this technique that 4 or 5 categories are used and that the cutoffs are probably best to be roughly evenly spaced. Although if you don't have any values in one particular category, then it's best to widen that category to ensure you've got an equal number of values, equal number of countries in this case. Some map makers choose to make the top color only 1 or 2 of their areas show that top color, so they are really emphasized on the map. And some map makers might even choose only 1 or 2 of their data points to be represented by the lowest color, so they're really emphasized on the map. That's especially if they're wanting to draw attention to the highest or the lowest countries. You can see some guidelines here on how to actually create a good choropleth map, and then how to decide on grouping your different classes. Now, why do it? Because it's really easy to visually see the data, okay? And it's nicely presented, and you can very quickly see a pattern that in Southern Africa, there's a very high level of GDP along with Northern Africa, and that the Sub-Saharan Africa is quite low and Central Africa is very low. So patterns become really easy to spot. It gives you a very good idea of change over space, and it even and very easy allows you to compare neighbors with each other to see how they do compare. Okay, there are some limitations though. It does work with averages for an area. So the whole of the wealth of this country, for example here, is somewhere in this category. And that's an average. Now, there might be huge variations within this country, with the northern region of this country maybe being much wealthier than the southern region, but because it's all been averaged, we just get the average picture. It also ends up with very abrupt changes where the boundary lines exist. So we think there's a big difference between here and here. a stark difference in color, and the wealth must drop off entirely. However, that's because this whole color is affected by the average. It's just an average. As later on, we'll talk about dot maps, and dot maps are used in a way that overcomes this particular problem. Another issue is actually the range, the fact that each category is a range. So we don't know the actual wealth of South Africa. We just know it's above 4,000. Likewise, this middle color, range color here, we know it ranges between 1,200 and 1,500, but we don't know exactly what the precise data for that location is. So that's another limitation of that particular technique. And what you would want to be able to do is not just know how to create one, but why you would do it in terms of why present your data on a map in this fashion, and also what some of the limitations are. Now, the technique is used widely. Here we have the SIMD website for multiple deprivation in Scotland, and we can see that the technique's actually using colours with blue. The darker the blue represents a higher score, a more positive score, and red represents a low score. And because it's an interactive map, you can hover over and find how those scores vary. And therefore, we can see, for example, in this area of Scotland over here, that there's very high scoring areas in this place called Bearsden, all ranking in the very dark blue. So they're getting scores of 10, as we can see over here. And then just across here, in an area called Drumchapel, we can see that they're all one, that they're painted out by dark red. And what we get to see is how this pattern does vary, not just across a small area, so we can see it by street level, but if we zoom out, we can then see it by area level. And if we zoom right out, we can see it at Scotland level and compare regions within Scotland. Other examples we can see, for example, here. This is the percentage of people who profess to be Anglican. Darker blue represents high levels. Over 32% of people are Anglicans in that area, and these central regions are quite low. We're using the green color here to effectively represent the data. Other variations, you can see black used here. This is a technique that's not strictly speaking shading density. It is a Choropleth map because color is being used at the average level, but we've got a range of colors and it's much more difficult to read because the colors are very distinct from each other. However, we do have an attempt at a color grading between dark green, moving through to the lighter greens and yellow, and then scaling up to red. So there is some degree of effort to show the average wealth across the planet. Here we have a common technique. In the United States, you'll see a lot of data presented at state level or within the counties of each state. And here we can see states where the number of people, percentage of people aged between 20 and 24, with this color being used for anywhere above 6.9 to up to 33.10. Very big range there. Obviously, the highest is 33.10, but we don't actually get to see where in the US that is, which is one of the weaknesses in this particular example. Okay, so that's all of the different ways that Choropleth mapping can be used. You've got to make sure you could apply it in terms of would it suit your data as your data being gathered across an area? Is it an average? And you also need to know some of the limitations in case you get asked about the suitability of this technique.